Hello everyone, welcome to our very first graphing video. So in order to do pretty much anything with your graph, you need to set it up first. So that's what we're going to do in this video. And in order to determine what to do with this nice blank piece of graph paper, we kind of need some data. So here we are, this is our sample data. We have some numbers for diameter and then the circumference that goes with them. So really step one is, which way should we do it? Should we do it this way or should we do it this way? And in order to answer that question, you first need to answer which one of these is going to go on the bottom. So the one that goes on the bottom is going to be your independent variable. That's the variable that you pick. And if we take a look at this, assuming we didn't collect this data ourselves, it pretty clearly looks like the diameter is the one that was chosen, right? 1, 2, 3, 4, 5, very even increments. And then these numbers don't really seem as nice, if you will. So the range here, we have to go up to 5. Over here is up to 16. Okay, so because there are fewer boxes here, more boxes here, we have less numbers, or a smaller range of numbers that need to go here. We're going to go ahead and put our diameter on the bottom. And our circumference on the side. Okay. Step 2 is determine how much space do you need to put in between each number. Now we could just go 1, 2, 3, 4, 5, but that's kind of wasteful of the paper, isn't it? We have all this space. Why would we cram everything right in here? Okay? So we wanted to make it look as nice as possible. It also makes it a lot easier to read. Okay, but we want this all spaced evenly. So what we have to do is first off figure how much space we have. Okay, so we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so we have 20 spots down here, and we need to go from 0, we can mark our 0 right here, all the way up to 5. And that actually works out pretty nicely, right? Because 20 has 5 go into it 4 times. So we're going to put every number on every 4th spot, okay? They'll make more sense in a second. So we go 1, 2, 3, 4. So we're going to put 1 here. 1, 2, 3, 4. 2 goes there. 1, 2, 3, 4. 3 goes there. 1, 2, 3, 4. 4 goes there. 1, 2, 3, 4. And 5. And look out. That worked perfectly. Okay. We need to do the same thing over here for our circumference. Now, you notice it's not a super nice number, but we have to at least be able to fit 15.7 on here, right? If we have 15.7 going way up here, it's not going to look that great either, right? We want to use our space as efficiently as possible. And just to make it a little bit nicer, we're going to say 16. We're going to round it to the nearest whole number. We want to make sure that we can at least fit 16 in there. So let's count here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Okay, cool. So let's say we wanted to go by ones on this side, right? So just 1, 2, 3, 4, 5, 6, 7, 8. We could fit that, right? Because the biggest number we could put was 25. What if we want to do some skipping here? Go 1, 2, 3, 4, 5. So every other one, we would need 2 times 16. Oh, we would need 32 spaces for that, but we don't have that, okay? So the best one that fits, well, it's not going to use every line. The best one that fits is going by ones. And I'm not going to write every single number, okay? I'm going to do every other number because sometimes it's just a little bit easier to read. And just because the 1 isn't written there doesn't mean it's not there. It's still there. 10, 12, 14, and 16. And you also could keep going, but really that's the highest number that we need to plot our data, so it doesn't really matter. Okay, one thing I do want to note is that particularly your independent variable doesn't have to be a number. Maybe your data is colors. You measured something where they were red, green, blue, and yellow. You would do the same thing, except there obviously wouldn't be numbers between you. Red, green, blue, yellow. Okay, keep them all nicely spaced. And that really is Gonna have it turn out to be the best graph that you can. Okay. Now, we're totally done, right? No, we're not. So, one thing is diameter and circumference. What's the unit there? It doesn't really say right now, does it? But it does mention some numbers, or some units here, okay? Both diameter and circumference are in centimeters. Now, it's very important to put that down because otherwise we don't know the scale of this. We might be measuring in centimeters, it could be meters, could be kilometers. Who knows, right? Unless you tell them. And we're done now, right? No, we're still not done. Okay. Right up here we got a big blank space, right? One of the most important things and one of the most missed things is the title. I need to know what this graph is about. It doesn't really make any sense right now. It could be about literally anything. So because we didn't necessarily gather this data, we don't really know what this data is for, we just know it's diameter versus circumference, that's what we're going to call it. Maybe it's diameter versus circumference of a marble. Maybe they're coins, maybe they're plastic pieces. But if you know that information, include it in the title. If you don't, then you can simply say something like diameter versus circumference. Okay, so we have our independent variable, all nicely spaced here, with the label and the unit. And we have our circumference numbers, all nicely spaced over here, going to fit all of our data with our title and our unit and the title of the overall graph. And we are ready to graph. We'll see you in the next video.